I'm going to say zip the outside and inside, and then make a list out of it. That list is going to be a multi-hierarchical list. PD pandas dot, I'm going to say M capital, multi-index, and then I'll give one dot, and I'm going to say from, I'm going to say tuples. Hey guys, what's up? This is Ashank David, and in today's video, we are going to talk about data frames. This is going to be data frame part 3 video where we have already recorded part 1 and part 2 video. So if you haven't watched those two videos yet, I will recommend you guys to watch that video first and then come to this video, because this video will be the continuation of part 2 video, and part 2 video is a continuation of part 1 video. So if you haven't watched those two videos yet, I will give the link in the description below, as well as I'll give the link in the I button so that you can go ahead and watch those videos first and then come to this video. All right. So without any further ado, let's get right into the topic. Okay. So in the previous video, we were talking about Pandas data frame. And here you can see this is the notebook that we have created. And this was part 1. After this, only in the same notebook, I've written part 2. In part 1, we learned about how we can create data frames, what exactly is a data frame, how we can select the columns, select the rows, and get the elements. And then in the part 2 video, we learned about the conditional selection. So after conditional selection, I told you how conditional Boolean data frames can be formed, and how we can pass different conditions and select those items or elements which we actually want from our data frames. So all of that I've explained you. Now in today's video, we are going to talk about data frames part 3. I've already written it for you guys. And here the main topic is going to be multi-index and index hierarchy. This is going to be the main topic of this part 3 video, where you need to understand about how we work with multi-index and index hierarchy in Pandas data frame, where we are going to talk about indexes of index. All right, so let's go ahead and start this video. Now, before I start this video, guys, I would like to request you people to please like, share, and subscribe to our channel, Code is Arcade, and don't forget to press the bell icon so that you won't miss any future updates. So, without any further ado, let's get right in the topic. All right. So, when we are talking about multi-index hierarchy, what exactly is a multi-index hierarchy? You see, right now, we say multi-index, right? Index hierarchy. What are indexes? Say, suppose we had this data frame, right? We had the same data frame. Okay. So in this data frame, we had these indexes, right? A, B, C, D, E. And the last video, I told you how we can reset and set the new indexes as well, right? So these are some things that I've told you. And these were the indexes that we were working on. Now, when I say multi-index, an index hierarchy means index of indexes. That means now these indexes can become the sub-indexes of some other indexes that can be applied onto those indexes. This is what you call as multi-index hierarchy. All right. So let's jump on to the main part, and let me just show you what exactly I'm talking about. So first, let me just create a multi-index data frame. Okay. So I'll write here multi-index data frame, and here let me just design a data frame like that. So I'm just gonna first import NumPy usually, because I want to create the data right first, and then I'm gonna use it in uh, the data frame that we are gonna create after that. So let me first import NumPy and pandas. So I'm gonna say import NumPy as NP, and here only I'm gonna say import pandas as PD. And after importing both the two libraries, now let us create some indexes, multi-indexes, and I'm just gonna write here some code that you see here. Okay, and I am gonna just, you'll get to know what I'm actually typing. So, and now after this, I am gonna create my data frame, which is going to have multi-indexes. Okay, so let me just tell you what exactly I'm talking about. Okay, so first let us understand about this. I have a list called equals to outside. Why I'm saying outside, you'll get to know why I'm saying outside. But as of for now, I'm just gonna say outside. And here I'm gonna create this as a list of, two major indexes. For example, I'm gonna just create a string here, and the first item is going to be G1, then again G1, and then G1 three times. Then here I'm going to write G2, G2, and G2 three times. I'm going to say dot split, okay? And this is going to create a list of G1, 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 G2, G2, G2 as the elements of the list called outside. And we can actually print outside in order to see how is it working. So we have got this, right? Now after this only, I am gonna create um, inside. Okay, I'm gonna say inside equals to, I'm gonna say here, let's pass some numbers here. Let's say 1, 2, 3, and then I'm gonna again say 1, 2, 3. Okay. Now, next, what I'm gonna create is going to be, you see here. First, let me just print it. So we have two lists here outside, which is the list G1, 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 G2, 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 and inside is 1, 2, 3, and 1, 2, 3. So the idea is here to have the inner indexes, like in this data frame, we had A, B, C, D, right? Okay, instead of A, B, C, D, I want 1, 2, 3, 1, 2, 3. Okay, and for the first pair of 1, 2, 3s, G1 will be assigned, and the second pair of 1, 2, 3, G2 will be assigned. That means 1, 2, 3, this will be G1. These first three will be G1. G1 is going to be the main outside parent index. Inside that parent index, you will have three indexes called as 1, 2, 3. And then same here in the downwards also, there will be G2. And in G2 also, there will be 1, 2, 3 indexes, right? So this is my plan actually. And to do that, I gonna use a list function in this case, and I'm gonna zip both inside and outside. How? I'm gonna say zip, I'm gonna say zip the outside and inside together, and the whole thing shall be given in a form of a list. Okay. So as I said that zip both outside and inside together in a one pack, and then make a list out of it. That list is going to be a multi-hierarchical list, multi-indexed hierarchical list. For example, let me just show you. I'm going to save this list into a variable called as, let's say, um, higher index. Okay. I'm going to say higher index. And now you see when I print higher index, see what we get. We got the list of different tuples here where we've got G1 with 1, G1 with 2, G1 with 3, G2 with 1, G2 with 2, and G2 with 3 in this case. So you see, what this zip is going to do is it is going to take this outside. So basically G1 will be paired with 1, G1 again will be paired with 2, this G1 will again will paired with 3, and then this G2 will again pair with 1, G2 again this will pair with 2, and this G2 will again pair with this 3. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. 6 outside indexes and 6 inside indexes. But at last, whenever these will be printed, this will be represented as 1 G1 and this will be presented at 1 G2 in this case, right? So the next thing that I'm gonna do is once I've got the higher index, now from this higher index, I am gonna use a pandas function for multi-index. And what is that? I'm gonna say here, uh, I'm gonna say the same name because at last I will be using the same name, higher index. I will say equals to now higher index equals to, I'm going to say pd pandas dot, I'm going to say m capital multi index multi-index, and then I'll give one dot, and I'm going to say from, I'm going to say tuples. Why tuples? Because in this case, at here we are seeing that it's a list of tuples only, right? List of tuples that are grouped together inside one list. That is how you get the zipped form of two lists in this case as a tuple. One element gets zipped into the tuple, and then it is stored inside a major list using this list function, right? And here I said from tuples, and in this case, I will pass my whole higher index itself, this higher index itself. Okay, this is going to update, and now this time I am gonna get the higher index as this multi-indexed hierarchy. So there is a difference here. Okay, what is the difference? If I print only this, if I execute only this, let's say I'm gonna execute it here. You see, when I said list of zip of outside and inside, it created a list of tuples which were zipped with the first element together, second elements together, third elements together, fourth element, fifth element, and sixth elements together in this one tuple in this case. But at last, when I use, because I use the same higher index variable in this case, and I used pandas.multi-index from tuples because it was already a list of tuples. So from the tuples, we took these indexes and it produced a multi-index form of it. And this is how a multi-index array looks like. A multi-index list looks like, or basically you can say multi-index looks like in pandas. Okay. Now using this multi-index, I am gonna create a data frame which is going to have multi-indexes. So let me just create a data frame now in this case. How we created this data frame, we said df equals to, I'm gonna say pd dot data frame as usual. And in this case, let's say I'm gonna pass my data in this case. So data will be from rand n, okay? But this rand n will not work. That means I need to first import this rand n here, right? Somewhere here. So I'm gonna say here import random import numpy dot random. Okay, I'm gonna say from import from numpy dot random. I'll say import rand n. Okay, I'm gonna run this also so that now I can use rand n function here, and here I can pass let's say I'm gonna pass a size of let's say 6 comma 2. That means 6 by 2 matrix of random numbers generated in a normal distribution. All right. Then here I'm just gonna pass the higher index as my index. See, you remember in data frames, the second argument was index and then the columns. So index, we have already created a multi-index, right? So I'm gonna just pass this higher index in this case as the index argument separated by comma. The third argument is going to be your columns, right? So let's say I am going to pass the column as, let's say I'm going to pass only two columns in this case. So I'm just saying A, and I'm going to say another column B, right? Then when I create this and when I say df, you see we get this nice multi-index data frame, right? This is how you will create your multi-index data frame. You can see that these are the main indexes, one, two, three, and these three indexes are having one main parent index which is called as G1. So why G1 I've taken? Because G1, so group one indexes. These are group two indexes, and the data is divided according to the representation that I have taken. So this is just a basic logical representation that I've taken in order to explain you what exactly is a multi-index data frame. Ultimately, we using so many different commands. We ultimately started from two lists only, outside and inside. We zipped them and we formed a list, and then we converted that list into multi-index using multi-index from tuples. Why from tuples? Because here we created a list of tuples which were zipped together for outside an index and inside elements, right? So this is how you are gonna get this particular, and then I've just passed this higher index into this particular data frame command, and this is how we got the data. So data was generated from um, this rand n, right? And we just created a data frame And just like this, we have got our multi-index data frame. I hope this is very much clear to all of you guys, right? All right, now let's say I want to grab some values in this case. And when I want to grab some values, I can directly use lock or ilock, right? Let's say I'm gonna use lock in this case. So I'm gonna just say, let's say if I want to grab the G1 one's values here, these two values here, I can just say here df of dot, I'm gonna say loc, and here I'm gonna give G1 as the string element inside lock, and I'm just gonna say dot, and from G1 get me only one, right? So I'm not gonna say one like this. I'm gonna say dot loc of one, right? So lock of G1 dot lock of one. You can use ilock also, but remember what ilock was doing. Ilock was giving you the indexes. Rather than just passing the name of a column or an index or a row, you just give the index number of that row or a column. But in this case, because we were using lock, I'm just directly using the names of the rows in this case. This will, I can write here a comment, grab me G1 first row. Okay. And when I execute this, there you go. You can see that we have got a series of these values where the A and B are the columns. These are the two values of this particular G1's one row for G1. I hope this is very much clear. Let's say I want to grab the whole G1 itself, all the three values, right? Just gonna say df dot df of, so the df dot loc, and here I'm just gonna directly say G1. That's it. There you go. We have just accessed our G1, the whole index in this case. All right, guys. I hope this is very much clear to how you guys can access our data from the particular data frame that we have created. This is your multi-index data frame in this case, right? All right. Let's say now you want to access the name and the name of the particular indexes, right? So I can just grab here, I can just write here df. df is your multi-index. Okay. Dot, I can say df. Dot, I can say index. Dot, and I can say name. I can actually say names. Okay. And when I use this, it says it's a frozen list of none and none. This first none is telling us that if I print df here, this first none is telling us that this doesn't have, these G1 and G2 doesn't have any column name. The second none is telling us that the inside indexes doesn't have any column name for this above here. All right. So in this case, we are not getting any column names in this case. All right. So now, and how to put the names in this case, right? This is the point. How to put the names into it. So here I can just say df of df dot index dot names, and here equals to, I can just say and pass a list. Just I can just pass a list here in this case. The first is was your first was for your G1 and G2, right? So let me name this as groups. And the second one is for your inside indexes, right? So let me just directly say, let's say numbers, right? This is your string, right? So you have to write it inside this. When I run this, now I have put the names of both the indexes in this case. So now if I print my df, you can see now we have the groups and numbers as the name of the two columns for the two indexes. I hope this is very much clear to all of you guys, right? So it's very easy to access the um, contents of the particular multi-index hierarchy data frame, and to get the indexes names and set the names, right? Now next, what we are going to say, let's say I want to grab some particular one single value in this case, right? So then what I will do, let's say suppose I want to grab G1's second row A column. That means I want to grab this particular thing on this case. What I'm gonna do is I'm gonna say df dot, I'm gonna say df dot, and I'm gonna say loc lock function, and here inside the square brackets I can just pass the main index, outside index, which is G1 in this case. I want to grab G1's second row's A column, right? So I'm gonna say G1, I'm gonna say dot again, and I'm gonna say loc lock of, I can say 2, and in this case I can just, rather than just passing any dot or any other function, now because we are not accessing the index, I'm just directly accessing the value, so I can just pass the column name there. I can just say A. This is gonna give me actually this particular value. So I'm gonna just write a comment here, grabbing G1's second row's A column, right? And this is how you do it. I hope this is very much clear now. Let's say if you want to grab G2's 3B, then what you're going to do, you're going to say df dot loc of, you're going to say 3, right? First, you're going to say G2, and dot, you say loc, and here you will pass 3 and 1. Now you are not accessing any index in this case. You've already accessed the index. So in this case, now you will just pass the column name, which is going to be B in this case, right? So I'm just going to say here D, right? And there you go. I've got the value, which is stored right there inside this. All right, guys. So this is how you can grab a one single element also from a multi-index hierarchy data frame. Now let's say you want to grab the sub-indexes, or you can say cross-sections, right? So when you want to grab the cross-section from a particular data frame, multi-index data frame, how would you do that? This is the main question. Okay, so I'm gonna do it like this. I'm just gonna say, let's say my DF is this, data frame is this, right? If I want to grab this whole G1, like this is one cross-section, okay? I grabbing one whole G1 out of this. So all the three rows are coming in one go. This is your one cross section. Okay. So if I want to do that, I can just directly say df of, I can just directly say df of, I can just say dot loc, and here I can just directly say G1. This is going to give me the nice cross section of only the numbers and the A and B in this case, right? If you want to particularly grab, let's say the whole G1, without using LOC, there is one more function which is called as df.xs. Now this sx, what it is going to do is it is used for grabbing the cross sections from a particular multi-index data frame. Remember, this is used mostly in the multi-index data frame part. Okay, so I'm going to just say df.xs, and xs, inside this xs, I'm just going to pass, let's say G1. This is also going to give me the same results. Oops, there is one problem. And what is the problem in this case? Oh, wrong brackets. Okay. I'm gonna give here in the brackets because xs is a function in this case, right? I'm gonna say xs, and here I'm gonna say g1. Now you run this and there you go. You have got the nice cross section of this particular g1. Okay. Now let us say you want to grab only this one and this one from both g1 and g2. So what I'm gonna do is I'm gonna grab only G1 first row, G2's first row. Okay. So both the first rows from both G1 and G2 should come in this case. What I can do, I can use XS for it. Okay. And how I can do, I can just say df dot, I can say XS, and inside this, I can say I want the first column, right? First row, right? So from the first row, comma, I can just set the level here. You can see here, if I open up the doc string, it says it takes the key is going to be the index in this case. Axis is going to be set to 0. That means it is representing a row by default, and the level equals to none. Level here is going to be telling on actually which particular thing. I'm going to say level is going to be this numbers in this case. So let me just pass this here. I'm going to say comma levels equals to, I'm just going to say it inside this numbers. Okay, there you go. I'm going to get these strings right there. Okay, from both, you can see if I print my df here, you can see from both G1 first row came and G2 first row came, right? I hope this is very much clear. This is how your cross section is working, guys. In this case, it's very simple to use. I know this is a little bit confusing, but yeah, this is going to be working like this. Let's say you want to grab from this particular DF, you're going to grab third row from both the G1 and G2. Okay. How will I write? I will write the same thing here also. Just I'm going to say 3. There you go. We have got the values from the G2 3 and G1 3 in this case, right? So this is how you are going to grab the cross section from a multi-index data frame. Okay. This is how you use multi-index data frame and data in index hierarchy. All right. So what did we learn today? We learned about what exactly is a multi-index data frame, how the index hierarchy works. So first we imported NumPy, we imported pandas, we imported numpy.random import rand in this case, and we created two lists here, outside and inside. Now from outside and inside, I zipped both outside and inside. This produced us a list of tuples where all the elements were zipped together, first with the first, second with the second, third with the third, and so on, till six with the sixth element of both outside and inside. And then we got a list out of it. So list of zipped outside and inside, which gave us a nice list of tuples. And then later on, I used multi-index. So pandas.multi-index.from tuple. And here I just passed the higher index in this case, which allowed us to basically get the multi-index here. Okay. Now after this, we created the data frames. And in the data frame, I passed the data and then I passed the higher index. Then I passed the column name, which gave us this particular data frame. All right, guys, we used log function. We learned how we can manipulate the index names in multi-index data frames. Then we learned about how we can grab a cross section of the data frame in this video. That's all for this video, guys. This is going to be the last topic of Pandas data frames. The next thing that we are going to do in data frames is going to be missing data, how you can handle that missing data. For example, here I showed when in the last part 2 video we were doing Boolean data frame, we were getting this NaN value and NaN value here, right? This is what you call as missing data. How you can handle this kind of missing data, I am going to talk about that in the next video. So I hope you have understood today's video well. You have liked today's video. If you have liked today's video, give a thumbs up, and thanks for watching. If you have any doubts into our videos, tell us in the comment section below, and I'll give the link of this notebook, the reference whole notebook. I'm going to give you the link of it in the description, which is going to be a Google Drive link. So whatever I've written here, I'm going to explain it much more better by writing more and more comments into this, and I will give you that notebook so that you can refer to that notebook and learn about data frames in this case, right? And this is the end of Pandas data frames concept. Note that we are going to use data frames as normal, like how we used to use NumPy arrays in this case, right? Now we will be using Pandas data frame as normal concept in other videos. So I hope you have watched part 1, part 2, and by now part 3 as well. So you have better understanding of how data frames in Pandas work. And there you go. I'll give the link of the other videos of part 1 and part 2 as well in the description below, and you'll get all the required links in the description as well. So if you have any doubts, tell us in the comment section below. I am going to clear all your doubts. And that's it for this video, guys. So that's all about data frames, guys. Thanks for watching. And this is Ashank David signing off. I'll see you guys in the next one. Till then, happy learning.